In this video, we are going to talk about arrays, how are represented in memory, and why arrays are such a powerful data structure. In simple terms, you can consider arrays as a list of elements. Here, we have a simple array consisting of 5 elements. Arrays can contain any type of elements. Here, we use integers, but we can also have strings, floating point numbers, or even objects. Most programming languages allow only one data type across the entire array, while others allow a mix of data types. Let's see now how arrays are stored in memory. Each element of the array is stored sequentially in memory, that is, one after the other. So in our case, we will have a slot in memory for the first element, integer 1, a slot for the second element, integer 2, and so on until all the elements of the array are stored in memory. How much memory for this array? You can pause the video now, calculate, and see what answer you get. So in our case here, each number occupies 4 bytes of memory, and we have 5 elements. So we have 5 multiplied by 4. That gives us 20 bytes of memory. The array elements are accessed by index, meaning that at index 0 we have the first element, at index 1 we have the second element, and so on. Notice that we start at index 0 with the first element. This is very important. Most people will be tempted to start at index 1 since we want to start with the first element of the array. Now, to access an element of the array, we just need to know the index. So if we want to access the fourth element, that is integer 4, we need to access the index 3. This operation is called lookup. It is very fast and done in constant time. Constant time means that no matter how big our array is, we can get the element in the same amount of time. Any element, actually. If you want to add an element to an array, you are looking at the push operation. This operation has also O of 1 time complexity because you are adding the element at the end of the array. However, if you want to insert an element into an array, then we are dealing with O of n time complexity. For insert operation, things are a little bit different. Let's say that we want to insert a new element before the first element of the array. What do you think it will happen? We will have to shift all indices of the array in order to accommodate the new element and also to match all the indices to the new shifted elements. And because we have to do all these operations, the time complexity increases, and we are seeing that the insert operation performance is O of n time complexity. N means the size of the array. Let's sum up and think when should we use arrays and when should we not use arrays. Well, you should use arrays when you need fast lookups, because as we have seen, it is O of 1 time complexity. Think, for instance, when you are designing a game and you have, let's say, 100 levels, you know exactly the index of each level, so retrieving a level is pretty much very fast. You should use arrays when you need fast pushes, meaning you need to add elements at the end of the array. And most importantly, definitely use arrays when you need your data to be ordered. You should not use arrays when you need to make frequent inserts and also when you need to make frequent deletes.